Our next presenters today is Mike Gilbart. His presentation is about a plane scale that we discovered in Oregon, an early 17th century navigational instrument. It is my favorite artifact that we discovered on the ship, and it's so unique that it's just, we can't believe that we found it on the Warwick. It's just one of a kind.
Thank you. Thank you, Peter. I'd like to thank you all for still being around on this last day of the conference at the very end, so thank you very much. So we've talked about everything. Let's just dive right into it. So the instrument I'll be talking to you today about is what's called a Warwick plane scale. Originally, the plane scale we found on July 10th of the first year by Mr. Carlos Cabrera. You can see here. It's a piece of wood with lines and graduated markings, approximately 20 by 6, 20.6 centimeters by 2.7 by 3.155. And where we found this was this is again the site plan from 2010. We found this between frames 3 and 4 right here. Now, as Katie said, you know, the good stuff is always at the stern, and that's where we found it. I can tell you from experience because those were the frames I was recording. And what's interesting to note about this plane scale is that we found this after we had dredged the site. I mean, this thing had survived the excavations by Tucker. This survived our dredging. And I'm not lying when I say this, that all of a sudden, one day it wasn't there, and one day it was. And it's amazing that we were there recording this, and Carlos had the eyes to see it, because I was actually recording on that site. He was right next to me, saw it, and brought it up. What we think happened is that during the shipwreck, that the plane scale somehow got wedged between the frames and the planking and survived, and we couldn't be happier with it. So just to give you an idea of what they look like, here's frames 3, here's frames 4. I'm here recording. Frame 3 had been eaten away by tornado worms. Frame 4 was a little more intact, and I can tell you there was very, very little, if any, space between what I believe it was under frame 4 and the planking. Again, right in here. So again, this is what it looked like when we brought it up that day. 20.7, 0.6 by about 2.7 by less than half a centimeter thick. Very fragile, very delicate, and what has happened with it is that these are the drawings from the first year. These are the mosaic, and this is what it looked like. So what we had, we weren't sure. We didn't know what it was. Now, if we take a look, said, okay, well, we have these here, we have these markings, we have the, the graduated scales. Originally, we thought it might be a Gunther scale, which again fits the time frame. At the same time, Edmund Gunther publishes on logarithms. He has the scale, and if we take a look at what a original Gunther scale looks like, this is what we get. Again, 3 sets of lines, graduated markings. But as more and more research was done, and then when we came back in 2011, after a series of putting the scale through deionized water to remove the salt, it improved and became cleaner. And as we can see here, not only did the markings come out, but we have numbers that came out as well. Might be hard to see here, but we have 10, 20, 30, 10, 20, 30. Let's see here. Yeah, 1, 2. No, that's 2. I'm sorry, 2 there. There's 3. As you can see, the markings here. So obviously, from the markings, we could tell it wasn't a graduated, or it wasn't a Gunther scale. Now, after the 2011 season, I decided to take this artifact on as a master's thesis. So myself and Dr. Piotr Wojciechowski, you know, being the archaeologists that we are, have zero time on the last day before I'm leaving to go back to Texas A&M. And so I said to Piotr, you know, we're smart archaeologists. If this is what came out on the front, what's on the back? So we flipped it over. And what you can see here is starting here, going up to right about there, and then radiating out our lines, and then another series of lines here. And not only did lines appear, but numbers as well. So what we have here, it's hard to see. I'll talk about the back of the scale in a bit. There's a 1, there's a 5, there's a 6, there's a 1, there's 0, there's 7. This looks like a 44 here, a 2 here. But obviously, lines radiating out. So we are quite happy with how the point scale had turned out. But again, at the time, we didn't know what it was. Again, just, sorry, that one's a little low, but numbers, lines started appearing. So here we have the mosaic done in 2011 showing the front and back. And please note that as you can see, we have lines here, but then on the back, those lines radiating out are on this side of the scale. That's important. I'll cover that in a little bit. So this is what we had. The original artifact here, and then this is a recent updated drawing by Mr. Doug Ingalls. Both of these are done by him, and I can't thank him enough for what he's done. But if we take a look, obviously we have 1, 2, 3, 4, 5, 6, 7, 8, up 10 to 90. Notice that they terminate at the same point in 10, 20, 60, 70. And if you take a look at the scale up front, you can actually make out 120 on that. So, you know, as I said before, it became obvious that it wasn't a Gunther scale. And I had spent quite a few weeks researching Gunther scales under the assumption that this was one. And you know what happens when you assume. Yeah, something out of you and me. But I went back and I was going through my research, and I had emailed someone in the Netherlands, and he had mentioned something, and I said, okay, well, why don't I take a look at that? And what that led me to was a publication that included this drawing, a figure of the point scale. And this and this, I'll just take a moment to let it soak in. But they're exact. They are exact. And so it became evident from this publication that it was a point scale. And so what can a point scale do? Well, according to Waters, these 3 lines enabled a navigator armed with a pair of compasses and a piece of lead to lay off on a plotting board the course sailed and the distance run during any given time, or the difference of latitude and the mean course between observations, thus finding his position by plotting. Basically, it's a plotting scale, taking 3-dimensional sailing and putting it on a 2-dimensional plane. Again, spelling for us for plane is different. It's not plane because it's simple, it's plane because it's referring to sailing on a plane. So where did this come from? This came from a publication which is called Speculum Nauticum, a looking glass for seamen, wherein they may behold a small instrument called the point scale, whereby all questions nautical and propositions astronomical are very easily and demonstrably wrought, lately penned and now published for the use and benefit of such as will make good use of it, by John Aspley, student in physics, practitioner of the mathematics in the city of London. Say that 5 times fast. So, for my purposes, I just refer to it as Speculum Nauticum. But what we need to note here, again, we have Warwick, 1619. This is the earliest publication of a plane scale that I've been able to find, and if anyone knows of anything other, please talk to me. But the year down here, 1624, 5 years after Warwick sank. And even in Speculum Nauticum, Aspley says at the time it was in use with very few. Now you've heard a lot of talks today about Sir Robert Rich, having his hands in little, pies and possibly privateering. It's safe to assume that if he's doing all this, he would have some of the most technologically advanced instruments and tools at the time for sailing. So what is Speculum Nauticum? It's a textbook. It's what it is. It's a math book with word problems. And for those of us who are American, I don't know if you remember those math books where you do word problems such as a train leaves Chicago going whatever, when does it arrive in New York? So basically this is a ship is sailing on a plane, sort of very similar to that. It's interesting to note that in the book, Aspley makes reference to that. It seems like he will produce more works of this. He says, this small book being the first fruit of my labors, containing such astronomical and nautical questions, are as wrought by the plane scale, which, if I should find to receive as free acceptance from thee, expect more of my labors in the same kind, and until then I rest. Thy friend in affection, John Aspley. So what do we know about him? This is it. This is the only thing, which is baffling to me, and is still, I would love to find something more by him, but that's all we know. Besides that, he did dedicate this to the Masters, Wardens, and Assistants of Trinity House. So this book was dedicated to Trinity House. So, again, what do we have here? In the book, we have, Aspley describes the lines of the scale. So, we have 1 through 8 representing the 8 rungs of a quadrant of the 32-point compass rose used by sailors at the time. We have 0 through 10 representing the 90 chords of said quadrant. And he does what we have here, 0 to 60, I'll show you in a second, but this is what's called your radius of the scale. And the reason it's always 60 is that in a quadrant, as you're going up, when you get to 60 degrees, what you have then is an equilateral triangle. So that 60-degree chord is also the radius. And then down here, it's what we call the line of leagues or equal parts. So, how do we use it? One of the first problems he says, the course is southwest by south, the leagues are sailed are 100, the difference of latitude is demanded. Now, I know when you guys signed up, you were told that there would be math at this conference, but there will be some. This is it written out, but you know what? We're going to do better. I'm going to show you how to use it. It's very complicated. And again, here's one of the diagrams here. And at the time in Speculum Nauticum, Aspley does not orient the diagrams as we would. That comes later on in the century, the standard orienting north at the top of your diagram. But for our purposes, I've oriented it correctly. So, course is southwest by south, the leagues sailed are 100, the difference of latitude is demanded. So let's figure that out. So, first thing we do is 0 to 60 as the diagram shows. That's going to be the quadrant. So we take that, set up a quadrant, A, B, K. The next thing is we know that it's southwest by south. Now if we look on the 32-point compass rose, that would be 3 points from south. So if we take the scale on the dividers. That's the distance. And on the diagram, that's where you put it. You mark a point. What do 2 points give you? A straight line. You could also do 5 from the west if you wanted to. It wouldn't make a difference. Say the course was southwest. It's 4. It'd be 4 either way. So we have that. We sail 100 leagues. We take that on our line along 100 leagues. We place the dividers along that line, and we mark it down here. Then all you got to do is you make a parallel line, extend your quadrant from the beginning, ad infinitum, as long as you need it to, which gives us, and we're using English leagues here, 83 leagues, 249 miles, or 4 degrees, 9 minutes of latitude. So that's how we do it. Let me give you another. Does that make sense to people? Quite simple, yeah? Simple triangles, If you have questions about it, come see me. I'll confuse you even more. Now, another example he gave in the book is, sort of like any textbook, you have a problem, and then you build on that. You make it a little more complicated. So in this one, you're sailing north from 50 degrees, you're at the 50-degree parallel, having 100 leagues to sail southwest by south. Again, diagram not oriented correctly. But first things you do is you go along that course 30 leagues. So we go you set up your quadrant, take your line of 3 along the line of rums. There's your line. Then you take your 30 leagues and you go there. Boom. Again, you set up, there's your quadrant, 60. You're going to go 20 leagues west-northwest, which is 2 points off of west. You go there. Boom. And then you go 60 leagues south. Take 60 on your line of leagues, go immediately south. That's where your ship is. Now, again, you want to go 100 leagues. The original course you wanted to go, that's where you need to be. You can find how far you need to go. You can find the course you need to go. And then you can also find your change in latitude. So there's some complicated problems in there, but for our purposes, these will work nicely. So on the back of the scale, originally, as we referenced the first line of longitude and the second line of longitude. What we have here, diagram, this is by Ernst Krohn, depicting those first and second lines of longitude. For us, he had used German miles, German leagues, which is 4 to the mile. So, 15 times 4 is 60. He never describes the back, or draws the back, I should say. And again, told you to remember that on one side, our scale has this, but on the back, where the first and second line of longitude should be, doesn't really seem to be anything. There's some slight markings up here, possibly, but again, if we're looking at the scale, this part is at the other end, which doesn't really make sense until we take a closer look at it. So, what we found out is that here is your 8 rums of a quadrant emanating out from a point. And basically what this is telling you is how far along each rum you need to sail to raise or lower 1 degree of latitude. So again, 20 leagues being a degree of latitude, but 156 and 107 don't make sense. So this research led me to another publication, The Seaman's Secrets by John Davis. And So the front of the scale and the back of the scale have both come from publications, one 1624, one 1627. These two publications they both appear on two different lists, one by John Smith and one by William London's in what's called a catalog of the most venerable books in England. So the two sources that have the front and back of the scale are the two books that are listed twice, the only ones listed on both lists. So again, but what we have here, this is in leagues. This is in leagues. But if we do the math, what this should be right here times 3 is 108, technically. What we have, 156, or 157 is what we should have. We have 156. We have, should be 108. We have 107. This is 45, I believe, in a third. That is 30. It's hard to make out, but there's the 3 and there's the 0. We have 44 down here. So the back is explaining to sailors how far along each rung you need to go in leagues or in miles to raise or lower 1 degree of latitude. The other part of Speculum Nauticum, he talks about the astronomical use of it. I'm just going to give you an example of what one of the questions might be. And another random part is that he just includes this use of the table of tides, which doesn't seem to fit in the rest of the book. But what says Speculum Nauticum lives on. It is so important that it goes through a bunch of different editions. 1624, 1647 is the 4th, and 1662 is the 6th. And then what's also important is that people are adding to it. And they're also, in these later editions, changing the alignment of the diagram. So north would be at the top of the diagram. But here we can see whereunto are added many new propositions in navigation and astronomy, and also a third book showing a new way of dialing. 1 minute, okay. So, who made it? Who invented it? Not entirely sure. My main guess is John Speidel. He references a scale in 1616. It also might be Edmund Gunther. Taking into account, I've looked at books on mathematical practitioners in London. These are the most likely candidates I have. And you can see by the dates that we have the other known instruments. And again, these are makers in wood. These are the most likely candidates so far of who might have made the Warwick plane scale. So some significance is that it was popular among seamen, but more importantly among Dutch seamen, and we have that in the archaeological record. According to Waters, it's easy and cheap, but it sort of gets eclipsed by the Gunther scale in England, but the Dutch continue to use it. And what we have here, we have the Hollandia plane scale. We have a list of what the officers needed, and as you can see down here, we have plane scale with the price. And again, the evidence that the Dutch continue to use this is in the record. We have other examples, a drawing from 1658, example from 1713. But again, do they say are they plane scales or are they Gunther scales? So you can see they sort of get more advanced and complicated. But in 1713, we have your chords, you have your rums, your line of equal leagues, and then your first line of longitude there. So what's going on with the Warwick plane scale? Right now, it's being conserved at Texas A&M University. Once that is done, it'll be returned to the National Museum of Bermuda to be placed in their new Queen's Exhibit Hall. As of now, if the questions that remain are did Aspley create more labors, more fruits of his labors. And then the other question is, can we find any earlier examples of point scales? As of right now, this is the earliest. And again, Warwick 1619, Speculum Nauticum 1624. So as of now, it is the earliest known example. So just like to thank a few people: AMARI, National Museum of Bermuda, Institute of Nautical Archaeology, Texas A&M, and the Otterite Society. So if you have any questions, come see me afterwards, but thank you. Appreciate it.